Okay, morning, Mr. Lisham here, and we're moving on with our trig, and we're going to finally learn something new this year in trig, and that's called reduction. Now, if you remember, I'll try and connect it to something we did last year. We spoke about reference angles. Okay, I'll try and quickly remind you this business. If, for example, I don't know what, they gave you sine theta equal minus 0,2. Okay? What we told you to do is first of all find the reference angle. Okay? So the reference angle, okay, sine theta reference is going to be 0,2. So we basically ask you to find the angle. It's not the same angle as this. It's a reference angle which always live in the first quadrant. So everything is positive. If I had the same question with cosine, I'll just get rid of that minus. Does that ring a bell? Not really. Anyway, let's just do that, okay? Then, okay, we will find it, okay? How would we find a reference angle? Simply by doing the inverse function of sine minus 1 of 0,2. We will get some kind of number. Maybe we can just get an answer. What's that? How much? 53.
Or 54 if you do round up.
Let's do the one decimal place. 53, comma.
It's 1153. 11.
One decimal place would be 11,5.
11,5. Fantastic. We'll just keep one decimal place. Okay? So that's the reference angle. That's not the angle that actually we're looking for. To get the angle that we're looking for, we need to use this little picture here. If sine is negative, right? And I can see sine is negative. Which quadrant could we live in?
Second,
The
Third and the fourth. Remember, the sine is always y over r, so it's underneath the x-axis below. Sine is negative here, so it's in the third or the fourth. Okay? So now we're going to use the reference angle, okay, because 11,5 is here. 11,5 is forever in the first quadrant. I need to find, there's actually two answers. Okay, if you remember from last year, mostly in these trig equations, we have usually two answers. So we're going to have one angle in the third quadrant and one in the fourth. How do I go from the first to the third and the fourth? Like that. If this is angle, theta, if I want to get this angle, what do you reckon I need to add to it?
180.
180. So if I want to go from the first quadrant, I've got the reference angle in the first quadrant, and I want to get the real answer, not the reference angle, which lives in the third quadrant in this case, I need to add 180. Let's just do that. Okay, so our first theta is going to be 11,5 plus 180, which is, what is that? 191,5. That's one angle. But we also said we have another answer, we should have another answer here. How do I go from here to here? No. What you're going to do, if this is theta, and you want to get here, you're going to do 360 minus theta, because this is the angle. From here all the way to there. So what I have to do is 360. I went all the way, and then I minus the theta. Okay? So the second angle is going to be 360 minus 11,5, which is 348,5. Check me, please. All right?
Yes.
I hope so. Okay. Great.
And then so to get to quadrant 2, you just go 180 minus this.
Perfect. All right. If not in this exercise, but in another exercise, I want to get to the second quadrant from the reference angle. What I got to do is do 180 and then minus the theta. Okay, so I'll just pause here for some questions. So now what we're going to do, this is what we've done last year. What we're going to do is come up with some reduction formulas for, we'll solve with the second quadrant. Okay, so if this is theta, a specific theta, we agree now that this is going to be 180 minus theta. If this, for example, was 20, then this is going to be 180 minus 20, minus 80 minus 20, which is 160. Okay? is maybe an example will help you. If this is 20, how much will that be? 160. 180 minus 20. Okay?
Oh!
All right.
I would've said that.
Now the question is, okay, where are the signs positive?
First and the second.
First and the second. In other words, what I can say here is this. Sine 180 minus theta
It's positive.
is positive, the same as sine theta. So these are going to be the same. And I'll ask you just to check it out. I want you to put sine 30. And then I want you to check out sine. What is 180 minus 30?
150.
150.
That's a
I want you to check both of them. Let's pause. Let's check both. So what we did now when we paused the video, we tried for different angles. When theta is 30, 180 minus theta is 150. When theta is 10, 180 minus theta is 170. And we found that they're always the same. You can try that with any angle of theta. Okay? Right? Okay, if you take the sine of 180 minus theta, you're always going to get sine theta. And that's not a coincidence. Because both of these live in the first and the second quadrant, the sign is going to be positive.
Yeah, but let's try with pies.
Let's try with cosine. Let's try with cosine. Let's try with cosine. Okay, so cosine theta, what is cosine here? Is it positive or negative?
Positive.
Positive. 180 minus theta, we're moving to the second quadrant. What about cos? Okay? Cos is negative.
Okay, now I'm
So
lost.
cos is negative here. Cosine theta
Cos
is
is
negative.
positive.
Cosine is positive here. So if I want to write down cosine theta, is it going to be the same? No, one is positive, one is negative,
Yeah.
right? So what I'm going to write
It's
is a minus
I'm
cosine theta.
So will that make them equal now?
Yes. Now let's look at an example. Let's look at an example. Okay? Let's take cosine 20. Okay? What should we check here? Cosine, what is 180 minus 20?
Where's 180 minus 20?
What's the key?
Okay? Now, according to what we wrote here, should they be equal? No. But if I put a minus here, then they should be equal, right?
No.
Put it, try it.
No.
And I can see it's a bit difficult, guys. All we're doing here is trying to, I'm introducing you to a bunch of formulas that you're going to have to remember. Now, maybe I should, at this point, stop for a minute and explain to you why actually we're doing it. Okay? So if, for example, I have cosine 170. Now, 170 is in the second quadrant, and it's a big angle. Now, I want to write it as a cosine of an angle that lives in the first quadrant. So it's going to be 180 minus 170, right? What's going to be the 10? Okay. Now, are they going to be equal? The answer no. They're not going to be equal. Cosine are not going to be equal. What do I have to do to make them equal?
You're negative.
One of them must be negative.
Okay. So that's called a reduction formula. It helps you take a big angle. That's a big angle, and reduce it to what do you call it? Acute angle. An angle that is smaller than 90. It helps you to take an angle that is larger than 180 and turn it to a cosine of an angle that is smaller than 90. Okay? In the sine, we didn't have a minus. In the cosine, we have a minus. Let's have a look at the tan. Okay? I'll pause it. Right, so now the question is what happens to tan? For example, I'll start with example. Let's say I had tan 170. I want to know tan 170. 170 is an angle that is larger than 90. I want to know if it's somehow to do with tan of what?
Negative tan 10.
You're actually completely right. Okay?
But why?
But why? Okay? So what we get here is the tan. What is the tan here? Tan is positive or negative?
Positive.
Positive. What is the tan here?
Negative.
Negative. So if we move to here, I can find the tan theta, but I need to slap a minus in front of it.
Okay.
Okay? So the answer will be, that was just for specifically for 170. If I have tan 180 minus theta, is going to be minus tan theta. And these are your reduction formulas of moving from the second quadrant to the first quadrant. I'll pause now here and then we'll do a little example. So you'll see why we need this. We haven't finished. We really only created 3 out of 9 formulas. We have another 6 to go. But I can see you really freaking out here. So let's see why we're using it. Or in an example. So they give us this expression, sine 180 minus theta over cosine 180 minus theta, and they ask us to simplify. Simplify meaning writing it in a little bit more simpler form. So whether you understood what I was talking about here or not, doesn't matter. At the end of the day, you need to be able to use these formulas. Now, instead of sine 180 minus theta, what can we write? According to that formula.
Sine is equal to negative sine.
No, don't think about it. Just look at here. The answer is that. Sine theta. Okay? Instead of sine 180 minus theta, see it says here, the board says write sine theta. Is this simpler than that?
Yeah.
Yeah, it's shorter, right? Okay? Whether you understand why I got there or not, doesn't matter. You need to remember it. Okay? Now, instead of cosine 180 minus theta, what shall I write? Negative cosine.
Okay.
Okay? Now you know me guys, I'm funny in that way. I like to write the minus in front. So we're going to write minus sine theta over cosine theta. Is there anything else I can do?
No.
Of course I can.
What?
What is sine over cosine? It's tan. Just tan. Sine over. Okay guys, that's oh, hang on.
What the hell? I'm sorry.
Yes. No. I need to actually show you something because I don't think all of you saw that. I did show it to my class.
Oh, sorry.
But I don't
Sine
think all
divided
the
by
class.
cos is tan. So
Yes.
if it was tan divided by sine, it would be cos.
No, let me explain. I'll explain. Okay, maybe you've not all been shown that. I showed to my class, but not all of you did.
Last year.
Yes, last year. So, guys, what is? Let's just quickly write down. What is sine theta? As we wrote last lesson. Okay. What is sine theta? It was y over r. Cosine theta is x over r. Tan theta is y over x. Now, check this. You haven't seen it before. Sine theta over cosine theta, using this, is y over r divided by x over r. And as we just did some practice with
That's
fraction.
y over x.
Okay? Okay? So,
Equal to tan.
breaking news. Okay? Yes.
Breaking news.
Tan theta from now on. Remember that it's also sine theta over cosine theta. Okay? I did show it to my class, I think, but maybe others didn't. Okay? Now we need to know it. So now you understand, and hopefully you agree with me, that this long expression is much more simple when you write as minus tan theta. Okay? Or how we do it, we use these reduction formulas. I'll pause here. So now, guys, now hopefully you have a better motivation to understand why we need these formulas. We simplify expressions. Now we need to look at not just how to move from the second quarter to the first, but from the third quarter, well, we already know that the third quarter is 180 plus theta, and from the fourth. Now, it's always going to be like that. So let's look at sine. Sine 180 plus theta. It's always going to be something with sine theta. This is always going to be something with cosine theta, and this is always going to be with tan theta. The only thing I need to remember is what? If I need to slap in a minus, yes or no.
Wait, so the first
I'll pause. Let's try and together figure out where do we need to slap in the minuses. Okay? If you don't know how we get there, it doesn't matter. Eventually you just need to learn and memorize it like a robot. If you do understand it, it's better because you remember better. Okay, sine is positive here, we said, right? Okay, bear with me. What is sine here? Is it positive or negative? Okay, what is sine here? Negative. So if it's positive here, negative there, do I slap in a minus?
Yes.
I slap in a minus to make them equal. Because sine here in the first quadrant is positive.
And that's a negative.
And here it's negative.
Okay.
So to make a positive and negative equal to each other, I need to slap in a minus. Thing doesn't matter where I put the minus. Can I put the minus there? I can put the minus there as long as there's no minus there. You can move from one to the other.
This is the
I don't think it's that difficult. Do you guys think it's difficult? Yes. Right, moving on. Cosine is positive here. What happens to cosine here? We're in the third one. It is negative. Okay, do I need to slap in a minus?
No, just leave it.
No, but I need, because this is negative. We said this is negative, and this is positive. So I must put a minus sign there.
Because cos is like negative.
Because cos is positive, this is positive, but this is negative. So I need to tell by minus. Okay, tan. Tan is positive here. What about tan here? It's positive. Tan is positive in those two.
So no negative.
So this is positive, this is positive. I don't need to put it negative. It stays like that.
Because in the third positive.
Okay? I'll pause again. So that was my third. Okay? This is from the second quadrant to the first. We're reducing it. We're reducing a second quadrant angle to the first. Here we're reducing a third quadrant angle to the first. We're always reducing to the first because the first is easier. And the last one, we're going to go from the fourth back to the first. Okay, first thing I'm going to write is simple. Sine theta, cosine theta, tan theta. But now I need to decide whether I'm slapping in a minus or not. Okay, let's look here. Is the sinus positive here or negative?
Sine is
Negative.
Negative. It's negative because it's below the x-axis. Here it's always positive. Do I slap in the minus?
Yes.
I slap in the minus because he is positive, he is negative, so I need to put a minus. What about the cosine?
Negative. No,
Cos
that's
is
positive.
Positive because I'm on the right side, the x's are positive. Okay, it's positive here, it's positive there. Do I need a minus? Don't need a minus. Okay? Lastly, tan. What about tan here?
tan is negative.
Tan is negative. Okay? It's negative here, it's positive there. It's negative here, it's positive there. I need a minus. Okay? Guys, at the end of the day, as I told you already a few times, whether you understood that or not, doesn't really matter. At the end of the day, you need to be able to use these formulas. You need to memorize them. And what we will do after the break, we'll practice some questions where we use these formulas. Bye-bye. Okay, so one last time before we move on to the examples. I know it was very tough, but possibly what I will probably do next time is just write down everything for you and just tell you guys, just memorize it. And actually, it's very easy to memorize. I'll explain now. Okay? Are you with me, Jojo?
Yes.
Okay, it's actually very easy to memorize when I look at it now. All you gotta do is whether it's 180 minus theta, 180 plus theta, you just write down theta. Okay, so those become theta, that becomes theta. Here, this also becomes theta. And the only thing we need to decide is whether we slap in the minus or not, right? Now, just like we clearly said, this is second quadrant, right? Like he said, 180 minus theta, that tells you it's the second quadrant. Now in the second quadrant, bless you, the sign is positive. So there's no minus. The cosine in the second quadrant, let's try the second quadrant. The second quadrant, the cosine is negative. So we slap in a minus. The tan in the second quadrant is negative, so we put in a minus. Okay? Now moving on to the third quadrant. In the third quadrant, the sign is negative, so we put a minus. The cosine is also minus, so we put a minus. The tan is actually positive, so it stays positive. And lastly, moving to the third quadrant, okay, the sine is negative, so we get a minus. The cosine is positive, so we get a no minus. And the tan is negative, we get a negative. So probably, in hindsight, that's all I should have done. Okay, it took us 19 minutes, I probably could have done it in 1 minute. Okay, I'll pause again, I can see there's a question. That's easy, right?
It's alright, sir.
Yes.
Yes.
So exercise 2 now.
No, I'm just doing something of my own for a second.
Example 2 is
I'm just doing a little thingy on the side.
Wait. Sorry, wait.
Okay, can we move on?
Yes, sir.
Okay.
Changes it possible.
It's always positive.
Yeah.
It's always positive. Whether it was negative or not negative, it's always positive.
The square is always positive.
Yes. Yes. Okay. So I'm just gonna write down. So sine square 180 minus theta. Cosine. Cosine.
Yeah, no. Yeah, no.
So these were like more rules.
Yeah, but you know, you don't have to remember. You can remember them, but it's kind of very common sense.
It's all gonna be positive.
It's all gonna be positive.
That's because you square it or.
Because we square the minus one.
Backside.
So that's easy. I ran off. No, I wrote it too close. No, that wasn't in the right place. I just need to write the whole thing there. More to the left, more to the left. So sine square, where am I? 180 plus theta. Yo, it's so hard to be a teacher. Cosine square 180 plus theta. Tan square 180 plus, not plus, minus. My brain's gone fried. Sine square 180 plus theta. Cosine square 180 plus theta. Tan square. One last one, I'll put it here. Sine square 360 minus theta. Cosine square 360 minus theta. Tan square. Okay. Right. So, is it gone? Yes. So, we had a bunch of rules not for the squares. Now we can have another rules for the square. And as we saw in these two exercises here, doesn't matter from which quadrant you move to which quadrant, the squares are always going to be the same. Because whether there was a minus there or not, when I'm squaring a negative number or minus, I'm getting rid of it. So that's going to be sine square theta. That's going to be cosine square theta. Okay, there's not going to be any minus. None of the minus survives. And that's tan square theta. That's moving from the second to the first quadrant. But the same thing will happen if I move from the third quadrant to the first. Okay? That's still going to be sine square theta. Because the minus evaporates. That's still going to be cosine square theta, and that's going to be tan square theta. And the same thing will happen if we move from the fourth quadrant. Whether some of them were minus or not, when we're squaring them, the minus doesn't survive. Okay? So they're all easy going. Square is much easier. Okay, I'll pause, make some space. See if there's any question. We'll do our last example. Okay, last example that will allow us to use these square formulas and the original reduction formulas. Instead of the square of cosine 180 plus alpha, what can I write?
You can write
Cos square,
theta.
or in this case I've got alpha. Okay, but you're right. So I get rid of that. The square is the same.
Yeah.
Okay, instead of sine square, I can write
Sine, you can write.
sine
Alpha.
sine square alpha.
Yeah.
Okay, because it doesn't change. The square doesn't change. Okay. Instead of the sine square, I'm also going to write sine square alpha. Got rid of the 180. And lastly, I've got one which is not square. Cosine 180 minus alpha.
It's going to be negative cos.
It's going to be time negative cos alpha because we're looking at this formula. Okay, it's a second quadrant angle moving to the first quadrant. I need to slap in a minus. What do I do now?
Cancelling monster.
Cancelling monster the sign, they get cancelled. What about that one? What do I end up with?
You end up with cos
So cos squared divided by cos. How much is that?
Negative cos.
It's going to be negative. I've got that negative. Positive divided by negative. I got negative.
Yeah.
And cosine squared divided by cosine. You're right, Finn. It's cosine alpha. That's the answer. Okay?
Cool.
All right. I will say goodbye here and let's carry on in class. Bye bye.